Hi everyone, welcome back to my channel. This is Mr. Budehas, your online math teacher. In today's video, you will learn quartiles for group data. In my previous videos, I already discussed the measures of position for ungroup data. Please check for the link in the description below. Now let's start. Let's learn first what are quartiles. Quartiles are points that divide ranked data into four equal parts. Each set of data has three quartiles denoted by Q sub I, where I is equal to 1, 2, and 3. The three quartiles are first quartile, second quartile, and the third quartile. The first quartile, it is a number such that 25% of the data are smaller in value than Q sub 1 and 75% are larger. It represents the middle value of all values to the left of the median. There are two parts of the median, the left part and the right part. For the left part, Q sub 1 represents the middle value of all the values in the left part of the median. First quartile is also known as the lower quartile. For the second quartile, it is a number such that 50% of the data are below and above in value than Q sub 2. It is also called the median. For the third quartile, it is a number such that 75% of the data are smaller compared to that of the Q sub 3 and 25% are larger. It represents the middle value of all values to the right side of the median. It is also called the upper quartile. The following illustration shows the position of the three quartiles in ranked data, where L is the lowest and H is the highest value. We have the four parts of the quartile. And this is our quartile 1, quartile 2, and the quartile 3. These are the steps in solving for quartiles of group data. First is we are going to construct the less than cumulative frequency column of the group data. The symbol is this one, less than cumulative frequency. Second, determine the Q sub I class. It's either the first quartile, the second quartile, or the third quartile class. To solve for the Q sub I class is first we are going to solve for I over 4 times N, where N is the total frequency. Then identify the closest less than cumulative frequency that is greater than I over 4 times N. The class of this less than cumulative frequency is the Q sub I class. Third, use the following formula to determine the value of Q sub I. After we know the Q sub I class, the next step is we are going to use this formula to find what is the value of the Q sub I. Q sub I is equal to the lower class boundary of the Q sub I class plus I over 4 times the total frequency minus the less than cumulative frequency before the Q sub I class over the frequency of the Q sub I class and multiply it to the width of the class interval. Now let's try some examples about the quartiles for group data. Number 1. Determine Q sub I or Q sub 1, Q sub 2, and the Q sub 3 classes for the frequency distribution below. We are just to find the Q sub I classes, the 3 quartile classes. These are the frequency distribution. First, we are going to find the Q sub 1 class. Solve for I over 4 times n with I is equal to 1 since we are looking for the Q sub 1. And n, of course, we will be using 45. So we have 1 over 4 times 45. Now, 1/4 of 45 is 11.25. Now, we are going to locate Q sub 1 class. Look for the class of the closest less than cumulative frequency that is greater than 11.25. That is 22. That is the closest less than cumulative frequency that is greater than 11.25. And that is our Q sub 1 class. This is the Q sub 1 class. Next is we are going to find the Q sub 2 class. Now, to find the Q sub 2 class, we are going to solve for I over 4 times n. Our I is 2, of course, since we are looking for the second quartile. And still, our n, or the total frequency, is equal to 45. And that is 2 over 4 times 45. 2 over 4, that is just equal to 1/2. So, 1/2 of 45 is 22.5. Now we are to locate the Q sub 2 class. We are looking for the class of the closest less than frequency or less than cumulative frequency that is greater than 22.5. And that is 32 because 22 is less than, but we are looking for the greater value for the 22.5, and that is 32. So this is now our second quartile class. Next is we are going to determine the third quartile class. Of course, we will be solving for I over 4 times n. Our I now is equal to 3 since we are looking for the third quartile. And still, we are using the total frequency, which is 45. That is 3 over 4 times 45. 3/4 of 45 is equal to 33.75. So we are looking for the closest less than cumulative frequency that is greater than 33.75. And that is 40. So this is now our third quartile class. Example number 2. Solve for Q sub 1 of the group data below. In our previous example, we are finding the Q sub 1, Q sub 2, and Q sub 3 classes. For now, we are going to find what is really the value of Q sub 1 in this set of data. First is we are going to determine the Q sub 1 class. We will solve for I over 4 times n. Of course, we will be using the value of I, which is equal to 1 since we are looking for the Q sub 1. And the total frequency is equal to 50. Now we have 1/4 times 50, or 1/4 of 50 is 12.5. Then we are going to look for the less than cumulative frequency that is greater than 12.5, and that is 14. So this is our Q sub 1 class. Second is, of course, we will now use the formula to find the Q sub 1 using this formula. we need to have the necessary values for this formula. The class interval is 41 to 45. Now, the lower class boundary or L is 40.5. Just subtract the lower boundary, which is 41. Just subtract it by 0.5 to get the lower boundary. And the value of I, of course, is 1 since we are looking for the Q sub 1. Then the total frequency here is 50. The less than cumulative frequency before the Q sub 1 class is 7. So this is our Q sub 1 class. Before the Q sub 1 class is 7. Then for the frequency of the Q sub 1 class is also 7 here. This is the frequency of the Q sub 1 class. And the class interval is 5. Substitute all those necessary values. Now we have Q sub 1 is equal to 40.5 plus 1/4 of 50 minus 7 over 7 times the class width, which is equal to 5. 1/4 times 50, that is 12.5, minus 7 is 5.5. Now 5.5 times 5 is 27.5 over 7. 27.5 divided by 7 is 3.93. 3.93 plus 40.5 is equal to 44.43. Therefore, the Q sub 1 or the value for the Q sub 1 is approximately 44.43. That is on how to find the value of Q sub 1. And that's all for today. Now I want you to answer these two problems under individual practice, and please document your answers below so that I can check if your answers are correct. For the first problem, this one, and the second problem. And that's all for today. Thank you for watching.